department. Concerns about traffic.
Hi everybody, how nice to see you again. I am very excited about today because we're going to be talking about water and why boats float on water or won't float if they're a different kind of shape than they need to be, and why bubbles are bubbles and how come they are making our water molecules change. How come they make water stretchy and make wonderful shapes that we can blow and create. All right, are you ready to sing our hello song? Here we go. Clap your hands, shake your shakers. Hello children, hello grown-ups, welcome to our class today. Let's all sing each other's names and then we'll sing and dance and play. Hi to the children, hi to the grown-ups, hi teacher, hi, that rhymes with papaya. Hi to teacher Michelle and teacher Missy and teacher Leck too. Are you ready? Say with your lips. Ba 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 ba. Now we're going to sing a song about the water and how it flows. Are you ready? Here's my water. Do you see it flowing here? It's so flowy. I love the scarf. It's a beautiful color, isn't it? All these colors. Here you go. I want to see you do something flowy with your scarves that you may have or your hands. Can you do it like that? Listen to the water, listen to the water, rolling down that river. Listen to the water, listen to the water, rolling down that river. What do you see by the water? I saw a waterfall by the waterside. I saw a waterfall by the waterside, splishing and splashing on the waterside. Oh, by the waterside, oh, by the waterside. Isn't that a fun song? Now, I love water, so I learn as much as I can about it. And water is a liquid. And a liquid is something that we can learn about because it's something we can feel. We learn about liquid by touching liquid. Here is some water. Do you see it? Liquid, and water being one of them, has three things you need to know about it before we tell you how it pushes up a boat. Are you ready? One thing is temperature. And we know by putting our finger in it to see if it's not too hot. We would not do it. We know not to do it if it's too hot. So we're going to put our finger in, and the nerves, what's telling our brain, the connection to our brain, it's going to tell us if it's cold or warm or in between. Now, this is cold because I put it in the refrigerator. Do you see how it's flowy? That's because it's not thick, right? So we also want to know how thick it is. That's called a big word that I love. It's called viscosity. Can you say it? Viscosity. We have some liquids here that are thick. This one's not so thick, right? Water is not thick. That's why it flows. And then we want to see if it's movement, if it flows fast or slow, if it's a liquid. Some liquids don't flow quickly, probably because they are thick, but maybe because they're sticky, or maybe because they're just slimy and they have this way of not flowing so well, so they stick a little bit to the sides of the place where they are. So that's called the movement, how fast it moves, or flow. So here's water. Now I'm going to show you some more liquids. Are you ready? We have one that is a little bit thick. Just a little. So when you see this in the container, it's not cold, it's not hot, because it's a little bit cold because it was in the refrigerator, but it's a little bit. But it's mostly medium, just room temperature. And it's a little bit thicker. Do you see how it doesn't flow quite as quickly? It flows, but not so fast as water. And it's a little bit sticky, so the movement is slower. So it's viscous, it has a little bit of sticky thickness, and that makes it flow a little bit more slowly. That's maple syrup. Can you see it? I should have shown you this part. Yeah? Maple syrup. The sugar in that makes it a little sticky. Now this one is also a little cold because when I feel it, I can feel the cold through the glass because it was in my refrigerator. And it's called sweet chili sauce. Now I'm going to tip it over, and it's going to even take longer than the syrup to go down. Ooh, it's very turtly, it's very slow. Even if I tip it faster, it's kind of very thick. So it's viscous. Is it more viscous than the syrup? It is. All right, let's see, is it faster or slower than the syrup? I think it's slower. I'm tipping it and it's like a little bit slower. So that means that if we measure it, water is the fastest and this one is the slowest and the middle one is the syrup. So now that you know the three properties of water, I want to tell you about what happens when you put a boat on top of water. There's 2 or 3 things that you would like to know, I bet. One of them is water will move away when you put something in it. That word is a very important word. Can you say displacement? Can you say it? Displacement. There was a very famous guy and his name was Archimedes. He lived 2,000 years ago almost. It's a long time ago. He said, you know, I'll tell you a story, but I went home after I met with the king and I had an answer to the king's question of how much gold was in the crown that he was going to buy from a man who said he would make him a crown, and how much there was not gold but something else, silver, that did not weigh as much, so you had to put more of it in it. And how would we know how much silver and how much gold was in the crown? You can't break open a crown and see it. So Archimedes went home and he took off his little clothes and he jumped into the bathtub. And when he jumped into the bathtub, what happened? The water splashed out, right? He said, oh, when I push my weight down into the water, that much water of how much I weigh goes out, I think. And he measured it and he was right. His weight was what was equally displaced. He moved as much as he weighed out of the way. And that's how much water was gone from under him and still maybe in the bathtub or maybe it splashed out. So he went back to the king and he said, King, I think I know how to tell you. Put the gold and the silver in a jar of water. Now, the one with more silver or any silver will displace more water because it's going to take more of it. And the gold with just gold, it's denser, it's more, how can we say dense? Dense is when you squish it down and it's thicker and heavier than if you had a lighter material and it's something that didn't weigh so much. So let me show you my gold and my silver. Are you ready? Okay. So here is the gold. And it's very heavy. And here is the silver. And it's very light. So when you put the gold in the water, I just want to show you the water. Let's see what happens. First of all, if I have the water and it goes up to here, the weight of the gold is going to push it higher. It's going to displace as much as I put in. Here we go. Oh, it did go higher. So if we drew a line, I'm going to take it out. I'm going to draw a line. I'm going to show you how much it was before and then how much it will be after we put the gold in. There's a line. Now, see my purple line? Let's see where I put it. I put a little one there. See the purple line? Okay. Now, when I put something that weighs pretty much in there, it's going to go over the purple line. Oh, I didn't put the line in the right place. Let me do it again. Ready? Let me show you with something bigger, actually. I think it will be easier. So that's what they did in the real story, but I'm going to put something else. I'll show you. See this? Doesn't weigh very much, but it's going to push the water. Let me see if that water's on the right line. Yeah, let me fix the line. Ready? Here we go. Is it okay to make a mistake? Yes, it is. All right, there it is. There's our line. Do you see it now? Yeah, here it is. Here's our line, okay? Now, I'm going to put this little thing in and see how the weight of this displaces the water and makes it go up. Look at that. There we go. It's above the line. It's up here and the line's here. That means that it didn't weigh too much, just a little, but it pushed it up. Now, if I force it down, it has air in it, so it's floating. But if I pushed it down, whoa, the water goes way up. So that weight of this object, plus my hand's pushing it more, so I'm giving more push, more weight, more force. It's making the water go up. Yeah. So that is called when the water is displaced. Now, the question is, what happens when you put a boat in the water? Well, a boat will float for a great reason. A boat could be made out of very heavy steel. But a boat made out of steel still has the bottom part below, and it has air in it. So hang on a sec, I'm going to go get my boat. Okay, this boat I made so you can make the same thing at home. And when you fold it like a piece of paper, there's air inside. See, it's round and puffy on this side. Can you see? So there's collected air on the bottom, in the hull it's called. So when I put this boat in the water, if it were really heavy, it would sink. But because it has air in it, let's see what happens. Now, there's a very interesting idea. It's floating very nicely, isn't it? What happens if we put more weight in it? Now, one reason that it's floating is because all the weight is spread out. It's not pointy like this. It's flat. So the flatter and more stretched out, it's going to float better. Yeah? So here we go. We're going to put some marbles in. And we're going to see how much weight it will hold. Will you count with me? Here we go. 1 marble, 2 marbles, 3 marbles, 4 marbles. Is it still floating? Yeah. 5 marbles, 6 marbles, 7 marbles, 8 marbles. Now it's starting to go down. It sank. So the water has to be strong to push it up. But it can only push up so much because gravity, what holds us to the ground, a pull, is pulling us down. So it's going to always be pushing against gravity. And now when you make something heavy, it sinks down because gravity is pushing it, pulling it down. Water's trying to push it up. But if it weighs more than the water, it'll fall. If it weighs the same as the water, it'll float. And that is a really nice word, and I'm going to teach you that word. That's called buoyant. It's going to be buoyant. Sounds like little boy, but it's B-U-O-Y. So check this out. Do you see my beautiful jellyfish? It's not very heavy, and it's pulled down by its weight a little bit, but not very much. So it's in the water, but not very much. Now a turtle weighs more than a jellyfish, right? So a turtle's going to go medium, halfway down, and it's going to be pushed up by the water, pushed down by the gravity, and it'll stay in the middle. Oh, but something very heavy, like this guy, he is going to be heavier. He's not going to go up because he has a thick shell on him. So he's going to be down here. And if you had steel with no air in it, Nothing at all. It would go down right away. So heavy things are measured by how much water they push away. This would push all the water away and it would go down. But a boat has air at the bottom. And in this light blue part here that goes under the water, it's actually floating the whole boat. So air is wonderful for floating. Guess what else it floats? Ice. If ice did not float, all the ice in the South Pole and the North Pole would go down into the ocean and everything would freeze. So we are really glad that there is air in things that we don't want to sink. And that way, in air, it has to be trapped, it has to be stuck in there, can't get out. If it gets out, you go down. So take a big breath in your body. Ready? We have a lot of air in us, right? If we go in the water, we would float. If we let all the air out, we would go down. Now what's really fun is that if you have salt in the water, salt is a mineral. It has a molecule, saline, and it connects to the water, so it's melted all together, and it pushes us up even more. It makes us float even more. So even if you let all your air out and there was salt in the water, then you would float. Now I'm going to show you some things that have air in it, even though you can't see the air, because you can't see air anyway, but you can see a cork. And a cork has little holes. Do you see the little holes all the way around? That makes it float. So when I put a cork in the water, it's not very heavy anyway, and it has air. So what do you think? Is it going to push the water out of the way very much? Let's see. No, hardly at all. Half is in the water and half is above. So very little of it is heavy, and it's just going down a little bit. Now I'm going to stop this so I'm not too close here, and I'm going to get a bigger piece of wood. Are you ready? Hi everybody. I'm going to turn this down a little so you can see. So when you see my wood here in the container, most of it is under the water. So when you go outside, can you pick up some wood? And there's a little air in it, but just a little. So it's heavier, and so part of it, then the water, is going to go underneath. And now, do you see a little straw? When I put the straw with the wood, it holds it up a little more. And it floats a little higher. I just want you to see it through the container there. Yeah? So you see how it's a little higher. So the air in the straw is lifting it up. And it's going higher. Pretty cool. So when you do this at home, here's how you can do it. You make something with a few straws. You have 3 straws, or 2 straws. Here, we start with them. And you take the 2 straws and you cut one in a little piece. You cut a little bit off the end and you fold it, the cut off pieces in half, and you poke them into the end of the straw to fasten them together. So you have a diamond shape. We'll show you in a minute. And then you fold the 3rd straw a 1/2 inch in from each end. So then you tape the 3rd straw to the other 2 to make the bottom of the boat. Do you see? Here's the bottom. And then you have foil and you cover it. And when you cover the straws, you basically have a boat. And then you put it in the water like Teacher Haya did. And you put marbles like Teacher Haya did and see how many marbles can fit in your boat. I folded a boat out of foil. You can do it that way, but I'm showing you how the air in the boat will hold it up even more. Now, sinking and floating is very fun because you can take anything and see if it sinks or floats. Some it'll fall apart, so you don't want to take too many things that are mushy. But you can take your toys. Hang on. Do you see my toy here? And we can see if it's going to be buoyant. Is he going to be buoyant? Is he going to float? Does he have a lot of air in it? Or no? A buoyant force pushes up on the boat while the gravity pushes it down. So what's going to happen with him? He's going to go down. When the two forces are equal, it'll float. So if more weight, more marbles, more plastic than air is put in it, it will be more likely to fall, be pushed down, because gravity will be stronger. And then the boat will move down, or the object in the water. And if you add weight, little by little, the boat will sink. And there you go, in the middle or sink. All right, let's try our friend. Are you ready? Let's see what he does. Is he going to go down more than the wood? I think yes. Let's see. Here we go. 1, 2, 3. Boom! Oh, he's down. He's not going to do it. Not going to make it. Let's save him. Oh, we saved him. He'll live. Okay. So, he is heavy. He has a lot of force of gravity pushing him down. And the water's not strong enough to push him up. Bye-bye, guy. Here you go. Want to go for a swim? Let's turn you upside up. Oh, he's still under the water. He will not float. But if we put a lot of salt in there, he would. All right. So, the next thing I wanted to talk about is bubbles. Bubbles are very interesting because bubbles change water. Water, as you know, is made up of our Mickey Mouse molecule. Do you remember? Let me show you. Ready? Here's the oxygen, the Mickey Mouse face. Here's O for oxygen, so here's a big O. Now, we need two friends to stick to him like ears, and those are hydrogen atoms. Are you ready? Here's an oxygen atom, and here's an ear, and here's an ear. Cute. Here's H for hydrogen. Can you say H for hydrogen? H for hydrogen. Now, that is the very, very littlest part that makes up the water. But we need a lot of these mice, a lot of these Mickey Mouse molecules. Now, one thing I want to show you is how do they cook together? Well, this little molecule is going to say, I see another one. And he's going to bond. He's going to hold on and hug and touch and hold tightly his little O friend. Can you say oxygen? Hello, Mr. Oxygen. You get to play with me. I get to play with you. So these are together like that by a bond, and this is a bond to its hydrogen on top of its ears. So we'll make it each a different color so you remember. Now the one thing I want you to know is the little circle and the big circle are both what we call atoms. That's what everybody and everything is made up of. Everything. And they're looking like they're not moving, but they are. They're always moving. So a chair is made out of atoms. And atoms are always moving even though the chair is sitting right there. Very interesting. So all these molecules stick together very tight. Very tight. But the tightest part where they stick together on a drop of water with all these guys on the inside, all these little atoms and molecules bonded together by their hydrogen. See how there's so many? Well, they're playing in the middle, very happy. But the ones on the outside, they're not moving as much. They're kind of staying there a little bit more. The ones on the edge are a little bit less mobile. They don't move as much. So we have a name for that. When there's a tightness around the edge that makes this a beautiful circle, because this circle is made of these little molecules, and there's your water, yummy water. It's called the circle. Hold itself together because it's tense on the outside. It's stiffer. And these little guys hold it together. And it's called surface tension. Can you see it? Surface tension. That surface tension makes the circle water molecules stay in a circle. So even if you splash, 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 they will come back to look like a circle. So here's my water, and it takes the shape of this container because they do move around, and they love to move around. But if you take a little drop of water and you splash it, it will turn back into a circle again. Now, if you make bubbles in water, nothing much stays there. I can shake it and we'll put some air in it. That's what makes the bubbles. But then it goes away. It doesn't hold its bubbles. It stays, it goes for a minute, stays, but then the water bubbles stop because of the surface tension. But if you put soap in water, what happens? Bubbles stay because the soap stretches those molecules apart. And dirt gets in and you need to clean something. That's how you get in. The soap separates these little Mickey Mouse molecules and your soap goes in and cleans it up. Pretty cool, huh? Well, I'm going to shake this and let's see how long the bubbles last for. Ready? Ooh, lots of bubbles, and they're still there. Much longer than the other bubbles in the water, right? So, what do you think? Bubbles are fun, right? Let's look at bubbles in a book. I want to show you really, really pretty ones. You know this book is my favorite book. It's called A Drop of Water, and it makes me see how magic water is. I'm going to show you pictures of the water and the bubbles. All right, that's how small the little water drops are. And do you know how many are on top of this little pin? How many water drops? They start so small you need a microscope. And if you were to look at them, you would see 300 trillion water molecules right on a drop of a pin. My goodness. Now here you see the water stretching, always a circle. And, well, not always. Here it's stretchy, stretchy, stretchy. But then it goes back into little circles again. That's because of the surface tension. They hold together like little magnets. Now, surface tension is so cool that you can put a pin flat on this. And it's not really floating. It looks like it's floating, but it's actually being held on the water surface by those molecules that are stiffer. And an egg dropped in here transforms the surface. It changes it and it splashes and it breaks the tension. So you can try that. You can try to put a little pin on top floating and see if you can get the surface tension to stay, even if you put a pin on it. What animal or little insect do you know that can swim on top of the water? It looks like it's floating. Do you know? Called a water strider. Now, when water meets the air, look, it opens up that brush. Pretty cool. We put air in there, do you remember? And it made a few bubbles, but it didn't change it too much. Now, here's our soap. Wow, look at the pretty colors. That is a special word I want to teach you. It's called iridescent. Can you say it? Iridescent. Now, they're so pretty and so delicate. Look at that circle. It's a perfect sphere. It's a perfect round ball. And it shimmers, and it's 500 times thinner than the human hair. Bubbles of water would break, but that's without the soap. The soap weakens the surface tensions and it makes it tension and makes it strong. It's stretchy and so it will stretch. Look at the shapes it stretches into. Are those pretty? Okay, let's see what we're gonna see. Ooh, more shapes that bubbles can be made into. Look how they shape themselves wherever they go. If you dip any wire frame into simple soap solution, the wire edges will be connected to the film of the bubbles. The film will shrink, the edge of the bubble will shrink and it'll hold on tight to the wire. Isn't that cool? Now what do we see? Oh, a bubble inside a bubble. When this frame was pulled out of the soap, 12 panels of bubble film. There's 12 sides connected at the center, and then a straw blew a bubble. We blew a bubble into the middle, and that made it the shape of a box. And that is what I wanted to show you about bubbles. Now, let's review. Are you ready? Okay, there are 3 properties, 3 things you have to look for water, right? How cold or warm, temperature, how smooth or sticky, and how fast or slow. Okay, that's important. Water is a liquid, and water is made out of molecules, our Mickey Mouse molecules. And when they connect to other molecules, they make a drop of water that always stays in a circle. Now that water, when it's in an ocean or when it's in a container, will push up something, and the weight of the object will, gravity will push down and the water will push up. And depending on the density, how squished in it is, or how spread out, how much air is inside, like our straw, will determine if it'll float or not. With a straw, it floats higher. With just a little air, it still floats. But with not very much air at all, our poor guy sunk. So we can play with this at home and see what has air in it and what does not. What is dense and will sink because it's solid, and what has like an ice cube, air, and it'll float. You can take an ice cube and put it in the water, and before it melts, you'll see. And you will be able to try it with little objects like corks and float those, and you can put a boat together just of corks and toothpicks. How fun is that? And make a raft. Here's a great story. When I was in the Galapagos, that's an island, I saw iguanas, and they're really scary and funny looking. And I said, how did they learn to live on the land before they lived in the water? Well, one little iguana from the mainland floated all the way on a raft, all the way, or they started on the land and they had to learn to live and eat from the water, floated all the way to this little island and got off the raft and got on the island, but there was no food. So he put his little toe in the water, and then he put a little more in the water, and a little more, and he went in the water, and then the wave was going, all the fish and all the food and all the krill all came up, and the iguana ate it and went back up. So the iguana learned how to eat from the ocean before it didn't. A little by little. That's called evolution. And we saw lots of iguanas. So they learned how to go down in the water, eat, and come back up. And they like the sun, so they stayed in the sun. And they stick their tongue out at you. They're not very friendly at all. So things that are in the water are very interesting, and that's what we're going to talk about another time. But the raft saved the iguana's life. They floated all the way on this wood with air in it to another place, and then he learned to live in that new place. All right. If he had a boat, it would have been easier, but nobody had a boat for him then, right? So it took a long time. So that's my story about floating. Even an iguana likes to float. Now it's time to say goodbye. If you are sad, it's okay to cry. Let's sing everybody's names, and then we'll sing more songs and games. Bye, teacher, hi, other rhymes with the bye. Bye to the children, bye to the teachers. Thank you, Wonder School, for everything you do for everyone. Ba 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 ba. Very nice, you guys. See you next time. Bye.